Bright QT. Every student matters.
Our next topic in this electricity chapter is electric power. Now, what exactly is meant by power? This is something that we on a daily basis we find people showing off. I have got a lot of power, right? Or we say that this particular thing is not that much powerful. Fine. What exactly is power? When we talk about power in physics, we say that the power is the rate of doing work, the rate at which a particular object or anything or anyone it does work, that rate of doing work is known as power, right. Now, we work when energy is supplied to us. Without energy we cannot work, right. So, we may also define power as the rate of supplying energy, the rate at which energy is supplied to us, that is known as power. Now, students, whenever this word rate of comes, that simply means divided by time, per unit time. So, we may also define power as the work done, rate of means per unit time, per means divided by, or I can say power when I have said rate of supplying energy. So, I may also define it as energy supplied to a body per unit time. So, this is what exactly power is. We may define it in all of these four options. Power is rate of doing work or work done per unit time. Power is rate of supplying energy or energy supplied per unit time, right. Based on these definitions, I can just represent power with the formula power is equal to work done upon time taken, as to how much work is done in how much time, that is known as power. Or I may also say that power is equal to energy supplied divided by time taken. This is what power is, right. So, power representing it with capital P is equal to W d upon small t, or it may also be referred as energy upon time. This is what power is, right. Now, the SI unit, the standard international unit of power is watt, and this watt is represented by capital W, right. Now, since the SI unit of power is watt, I may also represent it as power. I have defined it, the SI unit is watt is equal to work done. The SI unit of work done is joules, or for that matter the SI unit of energy is also joules, divided by time taken. The SI unit of time is seconds. Watt can be represented by capital W, joules by capital J, and second is represented by small s. Fine. Now, there are two things that may be asked from us. First thing is, we will be asked define watt. Now, if I am asked to define watt, I am going to simply write what is the SI unit of power, that is it, right. But if I am asked define 1 watt, remember we have done it in the case of potential difference in current, define ampere and define 1 ampere, define volt and define 1 volt, there was a difference between them. Similarly, we see here define watt and define 1 watt. When it is just simply watt, that means we will be saying that it is the SI unit of power. But when it comes to 1 watt, then we will be defining it with the help of its formula. How? I will say that 1 watt is the power of a source when 1 joule of work is done in 1 second, or 1 watt is the power of the source when 1 joule of energy is supplied to it in 1 second. Got it? So, this is our 1 watt definition. Got it? Fine? Good. Now, we have said that the SI unit of power is watts. Fine. It is a very small unit actually. So, we take some bigger units. Now, bigger units are, one is kilowatts. Now, what is this kilowatts? We know that wherever it is kilo, kW, it means 1000, or we can say 10 to the power 3 watts. Similarly, there is yet another bigger unit, that is megawatts. Megajoule we will be studying later. Now, megawatts represented by MW capital, 1 megawatt is equal to 10 to the power 6 watts. So, these are certain bigger units. Just for your knowledge, this power was actually initially in India, it was measured in terms of horsepower. Horsepower was the older unit of power, right, represented as HP, and in 1 horsepower there were considered to be 746 watts. So, now there are two things, try to relate what I am saying, just making you confused in language. How many watts are there in 1 horsepower? 746. Or how many horsepower are there in 1 watt? So, now if I am asking about how many horsepower, it will be 1 upon 746 horsepower are equivalent to 1 watt, right. This is the older unit of power. Got it? Fine. Now, this power, quite importantly, let us relate a few things about power. Bit more. We said that power is equal to work done upon time. Got it? If you remember, earlier in this chapter, we studied that potential difference, or V, was equal to work done upon charge moved. So, if I take the value of work done from here by cross multiplying, I will find that work done is equal to V into Q, potential difference into charge. Putting this value of work done over here, I can get what? Power is equal to potential difference multiplied by charge divided by time, right. Understood? Now, one more thing, I am going in the flashback. One more thing we have studied was I was equal to Q upon T, current is equal to charge upon time. So, when I find Q upon T here, I can replace Q upon T with I. So, this is another derived unit of power that we get, that P is equal to V into I. Remember, the initial was power is equal to work done upon time, as well as power is equal to energy upon time. Now, we have got a different derived unit, P is equal to V into I, right. Now, an important thing to consider is when I am writing P is equal to V into I know that V is equal to IR, this is stated by Ohm's law. Similarly, I will be equal to V upon R. Now, if I replace this value of V, I will get another unit. How? P is equal to V into I. Instead of V, now I am replacing it with V is equal to IR, and I remains the same. So, we get another derived unit, that is power is equal to I square R. Got it? Right. Now, it is my wish, here I have just put the value of V is equal to IR, but rather than replacing V, I can also replace this formula as I. So, actually I have got P is equal to V into I. Now, I will keep V as it is, and rather than writing I can also write I is equal to V upon R as per Ohm's law. So, now I will get yet another formula of power that comes out to be V square upon R. So, there are many derived formulas for power. We need to remember them, right. So, we have seen P, power is equal to work done upon time as well as energy upon time. It may also be represented by P is equal to V into I, or P is equal to I square R, or P is equal to V square upon R.